Okay, next up we have Abhinav. So Abhinav is a high schooler at the Jefferson High School in Virginia, and he will be
Hello.
speaking about using transformers and BERT, which is actually the same technology that Bharath was talking about, but different in an entirely different context. He's going to be talking about it for Twitter feeds. Thank you. Go ahead and get started, Abhinav.
Thank you. Oh, sorry. Okay, is everyone able to see the presentation clearly?
Yes, you're good.
Cool. So yeah, my name's Abhinav, and the project I did was utilizing BERT for natural disaster, for reading tweets, and from these tweets, determining whether that tweet subject matter was related to natural disasters or not. And so the reason for this was pretty simple, right? The reason for this was pretty simple because natural disasters are incredibly devastating, right? And so by reading social media feeds and using them to determine whether, the specific post is talking about a natural disaster, an earthquake, a tsunami, a snowstorm, whatever, that lets us essentially create a sort of warning system, right? We use our model on live. We can apply this model, right, to live Twitter data, and then if the majority of these tweets seem to be talking about natural disasters, then we can use our warning system and be like, yes, there's likely a natural disaster happening right now. Now, the second motivation for this project had to do with BERT itself, right? So BERT is a very recent development in natural language processing, but despite that, it's already incredibly impactful and it's become incredibly notorious in the field of natural language processing. So BERT stands for bidirectional encoder representation form, bidirectional encoder representations from transformers. That is what the full acronym means. And there's not enough time to explain it fully, but throughout the presentation, I'll try to give everyone a general idea of how the architecture works. And so essentially, BERT is incredibly powerful. And with this project, I was hoping to develop a proof of concept, right? If it's true that BERT is able to detect whether tweets are talking about natural disasters or not, then we can extend this to other applications, right, involving social media or whatever. So the specific solution I used, right? So I did a multitude of experiments, but the final experiment, the final model, worked it with this specific pipeline. So the pipeline was as follows, right? First, BERT was utilized for feature extraction purposes, and then from there we passed those features into a convolutional neural network as embeddings, and by doing this, we were able to classify each tweet into one of those two distinct categories. And so this method had incredibly high accuracy, and you'll find out about that in a later slide. So the data used, right? So the initial data set was simply just a Kaggle data set, right? But then from there, I took that data set and cleaned and curated it. I dropped null values. I got rid of, I cleaned the text. I got rid of all the ones that seemed weird. And, so with the text, what I did was I got rid of stop words. I got rid of unnecessary characters and symbols, right? Because those won't tell us anything, right? Those won't tell us if the tweet is related to a disaster or not. And then once I did all that, the number of disaster-related tweets in the data set was 3,271. And the number of disaster unrelated tweets in the data set was 4,342. And you can just look right here and you can see that you can see some details about the data set. You can see how most of the tweets are on the longer side, right? Because you can see how there's like this spike. And in addition, you can see that the tweets that were related to disasters were more likely to be shorter than the ones unrelated to disasters, if that makes sense. And then right here at the bottom, you can see, you can just see the actual tweets and you can see the text clean. So the text is the original tweets. The target is the classification, whether it's related to disasters or not. And the text cleaned is the new text once I got rid of the stop words and special characters and whatnot. So the actual AI. So basically just to explain how BERT works, right? So BERT is a semi-supervised learning model, which means it takes advantage of both unsupervised and supervised learning techniques, all right? And so when people are referring to using BERT for a project, what they mean is they're a specific BERT model, because there's actually a bunch of different BERT models. Now, the two main architectures when people are talking about BERT are BERT base and BERT large. The only real difference between BERT base and BERT large has to do with their size, right? So BERT base has only 12 layers of encoder model, and BERT large consists of twice as many, with 24 layers of encoder model. Also, BERT base has 768 hidden units, while BERT large has 1024 hidden units. Also, BERT base has 110 million parameters, and BERT large has 340 million parameters. And so because of this, BERT large is much more powerful than BERT base, but also because of how much heavier and larger it is, it's not always practical to implement, right? Because it's just so much slower, right? The inference time for BERT large is comparatively higher than that of BERT base. All right, so in order to actually create this model, this program, what I did was I used TensorFlow and Python. Uh, and that's the general gist of it, right? It was a very there's no fancy technology used beyond this, just Python and then the TensorFlow library and other related machine learning libraries like sklearn and all that other stuff. And so that was a very straightforward process. There's nothing too fancy to talk about when discussing the program, the actual technology. Now onto the actual experimentation, right? So the first experiment, it was a very straightforward pipeline. I used a count vectorizer, then I used a TF-IDF transformer, and then from there, I just used a simple multinomial naive Bayes model. There isn't enough time in today's presentation to describe what all those terms mean, but just as a quick summary, count vectorizer is just a way of tokenization. TF-IDF is a way of getting a specific representation. And then from there, the multinomial naive Bayes model is just a probabilistic learning method that's really popular in natural language processing. The second approach, experimentation, was just logistic regression. There is no fancy pipeline here. All I did was I threw a logistic regression model, a sigmoid function at the data, and that was it. And yet, despite it being so much simpler than the first method, it got almost identical results, just a little smaller. Now, the final approach was the one that we actually care about. That was the final experimentation. And so essentially how this one works is we removed all the punctuation stop words, right, to get the clean text, dropped null values and all that. Then what we did was we used something called, we used BERT's full tokenizer. And what that did was it helped tokenize the data, right, which is important. And then from there, we use the BERT-based model for feature extraction. And then from there, we use these BERT model features as the embeddings to our fine-tuned convolutional neural network model. Now you can see right here in the figure what that convolutional neural network model looks like, right? But just to go into a little bit more detail, the way it worked was there was an embedding layer, and then there were 3 pairs of convolutional one-dimensional layers, right? Each of it which used the ReLU activation function, and then one-dimensional max pooling layers. And afterwards, they just had 3 pairs of layers that are concatenated. These 3 pairs of layers are concatenated, passed through a dense ReLU layer, a dropout layer, and then finally a dense sigmoid layer. If you don't understand some of that terminology, that's okay. It's not really important. All you need to understand is just there's a bunch of different layers, and there's a bunch of different math involved with those layers. Beyond that, it's not too important to understand the details for the sake of this presentation. And so just some learnings from this presentation. BERT's powerful, very straightforward. It's true that the final approach we used wasn't pure BERT, right? It was also, a CNN. There's a lot of other stuff involved. So to say that the only reason the model was successful was because of BERT would be unfair to the other developments in machine learning that made it possible. But if you consider all the awesome things BERT has done over the past 3 years or so, it's very obvious that BERT had played a big role in this model's success, right? That model we created, that pipeline we created was incredibly impressive, right? It got near 100% accuracy. 99.73% accuracy is very high, right? Having accuracy for this type of model, right, if anywhere in the 90s would be particularly impressive, but 99.73% accuracy is just insane. All right, so for the future, I'd like to flesh this project out more so that it can be a more proper warning system for natural disasters, maybe make it a proper app or website, because essentially the goal for this project is to make a system for people who don't keep up to date with the news and whatnot, right? These people might not be typically aware of these sort of things, natural disasters and all that. And so this would be a good early warning system. And now you might be thinking, right, there already exists warning systems for natural disasters, but the idea here is that by using social media posts from other areas, that we might be able to find out about a disaster before it becomes worth mentioning on the news. Now, of course, this sounds like a bit of a stretch of the imagination, right? Nowadays, whenever there's a big storm or something like that, the news will cover it weeks, even months in advance, right? Because they're always monitoring the weather. That's their job. But who knows? This could be like an extra tool for the more unexpected ones. Now, again, you might be skeptical, right? Isn't it kind of naive to think that if a natural disaster is so sudden that the news doesn't know about it, that some dude on Twitter would, right? It doesn't make sense. And yes, there are admittedly lots of flaws in this idea, but the point is that this project was basically a basic test, a proof of concept, right? And now that we know that this sort of thing is possible, that BERT is this powerful, we can flesh it out and maybe use other types of data sources. We can build something really incredible. It doesn't have to be weather, natural disasters related stuff necessarily, but just the fact that this is possible at all, that it's possible to predict this sort of thing with this degree of accuracy and power, that alone means a lot for future endeavors. So yeah, thank you. Any questions?
Thank you very much. I think you may have answered a lot of the questions. I think I just wanted to kind of add one thing, which is, I think we're seeing, particularly even as we look in the news, that there are many countries in the world where communication is either structurally impossible or is being blocked. And in many of those cases, some of the institutional structures don't work, and social media has clearly been seen as an alternate way to communicate. So I think there's many options like that. So thank you very much, Abhinav.